Welcome to another topic on O-levels physics. Today we'll be talking about the types of lenses. So first we'll be talking about a converging lens. And as the name suggests, a converging lens tends to converge the light rays onto a single point. And at the point at which all the light rays basically converge, that is known as the focal point, as you can see over here as well. Now the distance from the optical center to the focal point is known as the focal length. And this is a lens, you can see the center of it is the optical center, and this is known as the principal axis. You can see how the light rays, which are basically parallel to the converging lens, are being refracted and thus converging on a single focal point where an image is being formed. All of these definitions have been simply repeated over here. Now, you must remember the thing that all the light rays have been refracted, as you can see. However, the light ray which passes through the optical center remains unrefracted and it passes undeviated through a straight line. Now, this is a thin converging lens. You need to know that in the converging lens, the upper and the lower portions are the thickest, whereas it is thinner at the center. Now, this is how we calculate the power of a converging lens. The power is inversely proportional to its focal length, so the power is power P equals to 1 over 5. The another thing is that those lenses which are thin have lesser focal length compared to those lenses which are thicker. Now, we have repeatedly studied the formula of magnification. Magnification is calculated by taking the ratio of the size of the image formed to the size of the object. And this is known as linear magnification. In linear magnification, a ratio is taken of the size of the image divided by the size of the object. Now, I'll be covering the next topic. In O-levels physics, you are several times asked to construct ray diagrams for converging lens. Now I'll teach you how to basically make them. So in all of the ray diagrams, you can basically make ray diagrams with the help of only two light rays, and the third light rays is not necessary. So as I told you above as well, that one light ray always passes undeviated, like it passes diagonally, whereas the other light ray, which passes parallel to the focal center, it is refracted and it eventually merges on to the focal point, and thus the focal length can be measured in several questions. What you will be asked to do is that you'll be asked to measure the focal length of the image from the optical center. Now here they've talked about how to construct basically a light array diagram, just like I taught you. Here are the principal characteristics of an image. As I told in the previous videos as well, that the difference between a real and a virtual image is that a real image can be caught on a screen, whereas a virtual image cannot be captured on a screen. Similarly, a real image is always inverted, whereas a virtual image is always upright. Upright means that its orientation is the same as the object, whereas inverted, as the name suggests, is that the image produced is opposite to the original object. Now, here are some of the ray diagrams. This table is extremely important. I can't stress its importance enough. Each of its column is repeatedly asked in the exam. Firstly, what you'll be asked to do is like they'll tell you that the object is placed at this distance, and they'll ask you that at what distance will the image be produced. So either you will have to construct an entire ray diagram, but even if you need to construct a ray diagram, so if you know that at which distance the image will be produced, you'll be able to correct your answer accordingly. And similarly, the uses of each of the following are extremely important. Now, and the key to remembering this is that you just need to remember the first three, and the last three will come to your own. You won't have to remember these because they're the exact opposite. For example, we know that an object when placed at infinity, its image will be produced at the focal point. So it is exactly opposite in the point number five. That if the object is placed at focal point, then the image will be at infinity. In number one, they were saying that if the object was at infinity, then the image will be at the focal point, and it will be at the opposite side of the lens. This is the same side of the lens, this is the opposite side of the lens. Now you'll have to remember all each of these uses. For example, the use of a telescope or the use of a camera and a human eye. So these are repeatedly asked in the MCQs as well. Now going back to the last part of this topic, the applications of converging lens. Now in medical instruments, we know that many of us use glasses in our everyday lives. So the glasses use the properties of these converging lens to help improve the refractive errors of the patients. Now those people who can only see such images which are closer to them, or for example, they have correct vision while reading a book. However, they can't see properly the television or they can't see properly distant objects. They are termed as myopic. What happens is that the light rays they converge in front of the retina. They don't converge at the retina, but they fall short of it. So what we need to do is that we need to use a concave or a diverging lens so that the light rays can be diverged and they can be beat at the retina. In contrast to this, hypermetropia or lopsidedness, or those people, for this principally occurs in older people who can easily view television or easily view distant objects. However, they have difficulty reading near objects such as the everyday newspaper. So what happens in them is that light rays don't beat it at the retina, they beat in front of the retina, or they beat behind the retina because the power of the lens is become extremely weak. So what we use is that we use a convex or converging lens to converge the light rays on exactly on the retina so that the image can be produced. Now, other uses of converging lens have been listed over here that you can see a camera and several objects such as microscopes, telescopes, binoculars, especially these three come in the same category. We know that what each of these the three does is that they converge light rays because with the help of microscopes or telescopes you can be able to see extremely distant objects in the space or extremely small microorganisms. So they can help to converge the light rays and help to enhance resolution. Now in the case of each of these a real image is produced. However, in the case of magnifying glass, the image produced is upright and virtual. Now, like I told you that a real image is anything which can be produced on a screen. So you know that a projector also produces an image on a screen. So the image produced is always enlarged, real, and inverted. And similar is the case with spectacles. The only exception is a mirror in which the image produces virtual and upright. Now, the other applications have been laser focusing and optical devices. We know that in the modern era, whereby laser, or it's known as the laser technology, the refractive errors can be easily removed on myopic or hypermetropic patients by removing the defect in the cornea itself. Thank you. I hope you like this small video.